In this video, we're going to have a look at how partial fractions can be combined with differential equations in a pretty difficult question actually. So let's start by expressing the fraction that's given to us as a partial fraction. So you want to write out the current fraction that's given, all over x plus 1 over 2x minus 1. And you want to separate that into the format of a over x plus 1 plus b over 2x minus 1. Now, what do we know about adding fractions? Well, we can cross multiply, can't we? We can say a times 2x plus 1 plus b lots of x plus 1 all over the denominator, which is the multiplication of the two when you're adding the fractions. So that's x plus 1, 2x plus 1 is all equal to the fraction that's given at the start of the question, is equal to 3x minus 3 all over x plus 1, 2x plus 1. Now, when you have only one fraction on both sides and the denominators match, the numerators must also match. So that's why you can say, I'm actually going to change the thickness of the pen again, it's too thick. We can say that the numerators are equal to each other. We can say a lots of 2x plus 1 plus b lots of x plus 1 is all equal to the numerator on the right hand side, 3x minus 3. You might have another method for going through partial fractions, that's completely fine. By the way, to get from this stage to get the values of a and b, you substitute in values of x to make each of these brackets equal to 0. I'll show you why. So to make this first bracket equal 0, you substitute in x equals minus a half. When you do that, the a term cancels out, and minus a half plus 1 is a positive a half. B is equal to 3 times minus a half is minus 3 over 2. Minus 3 over 2, take away 3. Well, 3 can be rewritten as 6 over 2, and then we can just combine these to get minus 9 over 2. So the reason I knowingly substituted in a value of x to make the first term equal 0 is so that we can find the value of b. We can now easily do that. We can say b is equal to minus 9. Let's do the same to the second bracket here. So let's substitute in x equals minus 1 into it. In that instance, 2 times minus 1 is minus 2, plus 1 is minus 1, so we have minus a. We substitute it in just to make the b term equal 0, so we don't need to include that. And it's equal to, well, 3 times minus 1 is minus 3, take away 3 is minus 6, in which case a is equal to 6. So we can say that this whole fraction here can be split into 6 over x plus 1, 6 over x plus 1, and then plus b, which is minus 9 over 2x plus 1. Perfect. Let's now move on to part B of the question. Spare me one more. Oops. There you go. Okay, so given that x is greater than 1, find the general solution to the differential equation. Oh, hold on. Did I delete the answer? Oh no. I'm just going to move this here. Sorry about that. Yeah, okay. So straight off the bat, it looks like this equation here is pretty similar to this fraction. So it wants us to somehow use these partial fractions that we split up into. How we can do that is, well, you can divide both sides by x plus 1, 2x minus 1, so that we get this whole fraction on the right hand side. Let's do that first. So dy by dx is equal to y lots of 3x minus 3 all over these two brackets multiply to each other, x plus 1, 2x minus 1. And then our goal always, before we integrate both sides, is to get all the y terms to one side and all the x terms to one side. So we divide both sides by y, multiply both sides by dx, and then, oh sorry, when you divide by y, it becomes 1 over y dy. And then when you multiply by dx, yeah, it goes to the top. And then you integrate both sides. So the integral of 1 over y is just ln of y. That's because when you integrate something, a fraction, where the numerator is a differential of the denominator, the integral of all of that will be ln of the denominator. And that's equal to the integral of this partial fraction that we found here. So that's 6 over x plus 1, and then minus the integral of 9 over 2x plus 1. So we're going to use the same concept here, but here we have to be careful because there's a constant involved. So when you integrate 1 over x plus 1, so let's put 6 outside the bracket. It'll help us visualize it. When you integrate 1 over x plus 1, that's just ln of x plus 1, because this differentiates to 1. But because there's 6 outside the bracket, when you integrate it, it becomes 6 times ln of x plus 1. Applying that same concept here, Here we know that 2x plus 1 differentiates to 2. So this numerator would be easier if it was just 2. But then to get from 2 to 9, you have to multiply by 9 over 2. So I'm just going to keep 9 over 2 outside the integral. And then you can say it's minus 9 over 2 lots of ln of the denominator, again, after you integrate. So there's ln of y again on the left hand side. You can say all of that plus c. Perfect. It wants you to find a general solution, which means it wants it in the form y equals something. But it's honestly just okay to leave it like that. This is a general solution. But here it's asking for the particular solution. So here you have to be a little bit careful. And it specifically also says, give your answer in the form y equals f of x. So let's start by finding the value of the constant, because it's giving you values of x and y that you can use to find the value of c. So let's do that. I'm just going to change my pen color. So let's substitute in y equals 6 and x equals 5. So we have ln of 6 is equal to 6 ln of x plus 1, which in this case is 3 plus 1, so 4. Oh, we actually don't even need to put in brackets. We only need to put brackets if when... Okay, let's leave it in brackets, it's fine. Minus 9 over 2 ln of... Well, 2 times x is 6, plus 1 is 7, and then plus c. Honestly, the best way is just to put this in your calculator, so I'm just going to very quickly do that. C equals ln of 6, take away 6 ln 4, plus 9 over 2 ln of 7. Okay, so it gives a fraction, which okay, let's stick in this fraction form then. 2.23. Okay, once we've got the value of c now, we can put it into this equation. And then to get the particular solution of just y, we apply the power of e to both sides of the equation. So when you do that, e to the power of ln y is just y. E to the power of ln x plus 1 to the power of 6. Well, before you can even apply it here, you have to take the coefficient forward as a power, because then you can say e cancels out with the power of ln, leaving you with just x plus 1 to the power of 6. Even before that, actually, I would recommend you separate this into separate multiplications. I'll show you why later. We can apply that same coefficient power rule here. So we can say it's minus e to the power of ln of 2x plus 1 to the power of 9 over 2. And the reason I wanted to separate it is, oh sorry, let's put minus here, because these are multiplied together in order for the powers to add together. That's how indices work. So you also multiply by e to the power of 0.223. Now that you've left it in this format, you realize that, well, e to the ln x plus 1 to the power of 6 is just x plus 1 all to the power of 6. But then you have to multiply onto that whatever this term becomes. So e to the ln cancels out again, leaving you with just 2x plus 1 to the power of minus 9 over 2. And then multiplied by e to the power of 0.223. So pretty messy, honestly, but this is your final answer, and this is how you have to deal with it in an exam. You have to be very careful. We know that even though the powers are added together, the individual indices are being multiplied together, and you have to separate it in this way. Pretty difficult question here. Hopefully that makes sense to you guys. Be sure to like the video if it helped and subscribe. I'd appreciate it a lot.